DSP stands for Digital Signal Processing. It is the process of analyzing and modifying a signal to optimize or improve its efficiency or performance. It involves applying various mathematical and computational algorithms to analog and digital signals to produce a signal that's of high quality than the original signal.
Coming to the applications of DSP, DSP is primarily used in arenas of audio signal, speech processing, radar seismology, audio, sonar, voice recognition, and some financial signals. For example, digital signal processing is used for speech compression as well as speech transmission for mobile phones.
In signal processing, sampling is the reduction of a continuous time signal to a discrete time signal. A sample is a value or set of values at a point in time or space. A sampler is a subsystem or operation that extracts samples from a continuous signal. The original signal is retrievable from a sequence of samples up to the Nyquist limit by passing the sequence of samples through a type of low pass filter called a reconstruction filter. There are three types of sampling. First, natural sampling. It is a practical method of sampling in which pulses have finite width equal to t. Sampling is done in accordance with the carrier signal, which is digital in nature. Second is flat top sampling. During transmission, noise is introduced at the top of transmission pulse, which can be easily removed if the pulse is in the form of flat top. Here, the top of samples are flat, that is, the constant amplitude, and hence it is called flat top sampling. Third is sample and hold. In sample and hold method, the sampled value is holded when it is received at the edge of the clock until the next edge where it samples and holds the amplitude at the instant with respect to the input signal. Of sampling frequency. In the first picture, we can see that when the value of Fs is 16 kHz, the number of samples is 8. In the second picture, we can see that when the value of Fs is 32 kHz, then the number of samples is 16. In the third picture, when the value of Fs is 64 kHz, then the number of samples is 32.
The duty cycle describes the amount of time the signal is in a high state as a percentage of the total time it takes to complete one cycle. Here you can see the different effects of the duty cycle. We have a 10% duty cycle, a 50% duty cycle, and a 90% duty cycle. In each case, the signal will get reconstructed at the receiver's end, and the power consumption varies from duty cycle to duty cycle. The sample signal can be reconstructed by passing it through a low-pass filter, provided that it satisfies the Nyquist criterion, which states that the sampling frequency must be twice the frequency of the message. So here are some of the filtered outputs of the low-pass filters. We have got a second order low-pass filter output, a fourth order low-pass filter output, and an output of a mixture of the second as well as the fourth order low-pass filter.